Hello students, I am Dr. M. Velmani, Assistant Professor, Department of Civil Engineering. Today we will discuss limit state design for flexural RC beams and their types. These are the list of content: introduction to RC beams, single reinforced beams, behavior of singly reinforced beam, design step for singly reinforced beam, doubly reinforced beam, behavior of doubly reinforced beam, flanged beam, behavior of T beams and L beams, design steps for flanged beams. Introduction to RCC beams. Beams are structural member that resist the bending, carrying a load from slab and transferring them to columns. In RCC, concrete resists the compression and steel resists the tension. For safety and serviceability, design follow IS 456-2000. Usually by the limit state method, the beams are mainly classified into singly reinforced, doubly reinforced and flanged beams. Singly reinforced beams definition. A singly reinforced beam has reinforcement only in the tension zone. Concrete resists the compression at the top, while steel bars resist the tension at the bottom. No compression steel is required if the depth is sufficient. These are the most common type: simple to design, economical for simple to medium span, and always design as under reinforced section for ductility. Behavior of singly reinforced beam. When loads act the top fiber compression and the bottom fiber stretch. Concrete resists the compression, steel resists the tension, and the neutral axis separate the two. In under reinforced section, steel yield first, giving ductile failure with warning. Over reinforced section failed suddenly, which is unsafe. Hence, IS 456 recommended under reinforced design. The strength depends on span, depth, and reinforcement provided. Design step for singly reinforced beam. The design procedure is for the following points: calculate the bending moment from loading, assume breadth and affinity depth, find limiting moment of resistance. If demand less than limit, design as a singly reinforced. Provide required tensile steel, check shear, deflection and detailing as per IS 456. Doubly reinforced beams definition. A doubly reinforced beam has a steel in both the tension and compression zones. It is required when the depth is limited but higher moment capacity is needed. Compression reinforcement increase the strength, control the deflection and improves ductility. These are the common in cantilevers, continuous beams and multi-story buildings. Behavior of doubly reinforcement beams. In these beams, both concrete and compression steel resist the compressive stress, while tensile steel resists the tension. This provides the more strength than singly reinforced beam of the same size. Compression steel also reduce the creep and shrinkage effects, making the beam durable. They are safer in seismic zones because they can resist stress and reserve the strength after cracking. Flanged beam introduction. Flanged beams are formed when the slab and beam are cast together. The slab becomes the flange and the beam the web. Example are T beam and L beams. They make economical use of concrete and steel and they are widely used in floor and bridge ducts. IS 456 specified the FIT flange width based on the span and support conditions. Behavior of T-beams. In a T-beams, the slab flange resist the compression while the web resist the shear and tension. This gives much higher bending strength compared to rectangular beams. They are more economical, distributed load effectively, and reduce crack due to the flange stiffness. Their capacity depends on the slab thickness and span length. Behavior of L beams. An L beam is an edge beam with a slab on one side only. The flange exceeds only one side, so stress distribution is symmetrical. Also less economical than T beams. L beams are stronger than rectangular beam and essential at slab edges. Proper reinforcement detailing is crucial. Design step for flanged beam. To design the flanged beam, find the effective flange width, calculating bending moment, check neutral axis location. If in flange, design a rectangular section. If in web, apply T or L beam design equation. Provide a tension steel anchorage into flange. Check the shear, deflection and crack control. Comparison of beam types. Finally, let us compare singly reinforcement for simple, economical but lower strength. Doubly reinforcement, higher strength, suitable when depth is restricted. Flanged beam, economical in slab and bridges. Strength order, doubly reinforced is more flanged beam. Flanged beams more than singly reinforced beam. The beam choice depends on the span, load and site condition. Thank you for watching this lecture.